I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, this video is for Geometry 4.2. We're going to apply congruence and triangles. And so we're going to talk about what congruent triangles look like and how to identify them. So first of all, congruent figures are figures that have exactly the same size and the same shape. And in congruent figures, the corresponding parts will be congruent. So this is what can be tricky sometimes. So here I have triangle ABC, and I have triangle FDE or EDF, right? We can name this triangle in any order, but if I'm trying to talk about these triangles being congruent, then there's a specific order that I need to list these in. So there's my congruent symbol. So what is triangle ABC congruent to? Well, I need to look at the corresponding parts. I need to identify the corresponding parts. So I see that side AB appears to be congruent to side FD. Side BC appears to be congruent to side DE. And side CA appears to be congruent to side EF. So I just highlighted the corresponding parts. So if I'm calling the first triangle ABC, then I need to make sure I go in order of the corresponding parts. So what point corresponds with A? Well, where does the yellow and the blue meet? They meet at F. So this would be triangle F, and then the next point is B, which would correspond to point D, and then E. If you do not write those points in that order, then that would be a non-true statement. So you've got to make sure that your points are lined up in the correct order. Now we can also see some congruent angles here, and those are marked by the little curves in the angle. So if it has one curve, they both have one curve, then those are corresponding angles that are congruent. So angle B and angle D, or I guess I should say angle ABC and angle FDE, those are congruent angles. Angle ABC is congruent to angle FDE. Angle BCA is going to be congruent to angle DEF. And what you'll notice here is if I go from B to C to A, then that means over here I go from D to E to F. So again, it should always match up with, the corresponding parts from one triangle to the next. So again, let's look at corresponding parts. These are the parts of a figure, either angles or sides, that are congruent to each other. So I know this is kind of a small picture. So let's talk about what triangles are congruent. So I see some sides that are congruent. So side DA is congruent to side BC or CB. You could call that either way. And side DC is congruent to side AB. Okay, so I have that. And then if you notice, AC is part of both triangles. So that's the reflexive property. AC is congruent to itself. So let's see if we can figure out what order this goes in. Now, if we figure out the angles and which ones go with what, we may be able to figure this out a little bit easier. I see a 1 mark here, and I see another 1 mark right here. So that means that angle BAC is congruent to angle DCA. BAC is congruent to angle DCA. I also see that angle ABC is congruent to angle ADC. And if you don't see that, compare it with the picture and look at what I'm talking about. They both have 2 marks on them. And then the last one is angle DAC is congruent to angle ACB. So how are we going to write that these triangles are congruent? By the way, are they congruent? Well, yes, they are. Why? Because all 3 angles are congruent to the other 3 angles as well as the sides. Remember, the green that I highlighted, the AC, is congruent to itself. It's, reflexive property. So if all the sides are congruent and all the angles are congruent, then the triangles are congruent because all the corresponding parts are congruent. So let's compare the letters. So it looks like B goes with D, A goes with C, and C goes with A. Now you see how these letters are repeated because they share a side. That's fine. So again, B goes with D. So if I call this triangle on the right side triangle BAC, kind of like I called this angle right here, then that triangle should be congruent to triangle DCA. BAC congruent to DCA. Okay, so let's see if this holds true. So let's look at corresponding parts. So according to this, BA, the segment BA, should be congruent to DC. Let's look at the picture. Is BA the same as DC? Yes, it is. As well as, for instance, let's go with AC should be congruent to CA. Well, sure enough, AC is congruent to CA. So you see how those corresponding parts match up. And so that would be the congruency statement that you would state using corresponding parts. The third angles theorem says if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So here I have triangle XYZ and triangle PQR. And so we're going to determine if these are congruent triangles or not, and we're going to use this third angles theorem to help us figure that out. So I see that segment XY is congruent to segment QR, and I also see that segment YZ is congruent to segment QP. Notice that I'm using the segment notation with the congruency, not equals, because segments aren't equal, distances are equal. And then the last one is segment XZ is congruent to segment RP. So I have three segments congruent to another three segments, so I'm good on that front. Now we need to look at the angles. Okay, so angle YXZ is congruent to angle QRP, and then angle XYZ is congruent to angle PQR. And I don't know about the third angle, but according to this theorem, if two angles are congruent, then the third would be congruent. And we're going to discover that more when we look at the theorem from 4.1. So we'll do that in class. So if the three segments are congruent and the three angles are congruent, again, using the third angles theorem, then we could say that these triangles are congruent. So let's figure out what our congruency statement would be. I would encourage you to try this on your own. So according to my angles, Y goes with Q. Let's see if that applies in the second statement. Sure enough, Y is in the same place as Q. X goes with R. Okay. Now, notice in the second statement that X goes with the P. Okay. And so in the first statement, the Z goes with the P. So we need to figure out what order we're going to do that in. So for sure, the Y goes with the Q. So I'm going to say triangle YZX is congruent to triangle Q. Now, where do I need to go next? So YZX, well, if you notice from Y to Z, I had the segment with the 2 marks. So that means after Q, I need to go to point P because that's the segment with the 2 marks. And then from Z to X is the segment with the 3 marks, and that is from P to R in the other triangle. So that would be your congruency statement. And the reason the angles are a little bit confusing, the way they match up, is because an angle can be written the same way forwards and backwards. So I could also say that this is angle ZYX congruent to angle PQR. And if we did that, then we would see that the Z lines up with the P just like it does in the first example. So that's why that's a little bit tricky, but it's not wrong the way that I did it.
I've been waiting way too long. Yeah, I've been down here trying to get it.